Spanning tree protocol. In this video I am going to talk about again STP. In this video we are reviewing some of the features that we have learned in the previous videos. For example, about the root bridge placement and also cost configuration, port priority configuration. Also, we will learn about the diameter, how we can use it, and actually this is a video for our practice and also for more learning about the spanning tree protocol. The first thing that I'm going to talk about that is the root bridge placement. You know that root bridge is the most important switch in STP topology, and you know that for configuring one switch as the root bridge, we should configure its system ID lower than other for example switch system ID. And how we can lower the system ID of one switch? You can reduce the priority or STP priority of that switch with this command: spanning tree VLAN ID priority and then priority. Maybe we should know first which place is the best place of the for one root bridge. Okay, here we need to consider multiple features. The placement of the root bridge is an important decision and often should be chosen to minimize the number of hops to the for example farthest switches in the topology. The design should consider where redundant connection exists, connections that will be blocked, and the ability or performance for the root switch to handle cross-switch traffic. Generally, root switches are at layer 2, layer 3 boundaries. They are residing in the layer 2 to layer 3 boundaries, and because of that we should for example design the root bridge in a place, okay, that this place is the best place about redundancy, about the usage of the links with highest bandwidth, and some other design consideration. Okay, and also let me to say that in most cases we are configuring one root bridge, okay, as the primary switch, and also we are configuring one root bridge as the one switch as the secondary switch, because we don't want to experience the major change in topology of network when the root bridge is failed. Assume that a switch 1 is not available and we don't want to switch 4 or switch 5 convert to the root bridge. Because of that, for example, you can configure one switch with the lowest bridge ID or the lowest priority and other switch, okay, after that. And all other switch should be configured with the higher priority. For example, one best practice scenario is that in switch 1 we can configure the bridge priority, okay, bridge priority as 0, and for example switch 2 as the secondary root bridge, we can configure the priority of this switch as 4096, okay, and for example for other switches we can configure the priority as for example 61,000, okay, 440, because we don't want to experience them as the root bridge, or any other values. Okay, this is desirable, but if you want you can use these values. Also, you know that we have a macro. With this macro spanning tree VLAN ID, we can configure root primary and root secondary. For example, if you configure a spanning tree VLAN ID root primary, the priority of that switch, for example switch 1, should be converted to the 24,576 if we didn't change the priority before. And if we configure a spanning tree VLAN ID root secondary in the switch 2, the priority will be 28,672. And for other switches we can configure the priority ourselves with the command spanning tree VLAN ID priority. Or if you for example doesn't change the primary, if you don't change the priority of the switch 3 or other switch, the priority will remain in the 32,768. And because of that, as you can see now, the switch A or switch 1 is the root bridge, and for example switch 2 is the secondary root bridge, and switch 3, switch 4, switch 5 are the for example other switches. And this switch now you know that cannot choose the root bridge role. Okay, it is the first thing that we should know. After that, here we have a feature, we call it diameter. We can use diameter for control the value of the hello time, or the, for example, forward time, and also maximum H timer or max H timer. You know that by default in STP, okay, the hello time equal to the 2 seconds. Let me write here because I want to show you the change. And after that, the forward time or forward delay time is the, for example, 15 seconds. And after that, we have other timer, max H time or maximum H timer. It is equal to the 20 seconds. Okay, but you know that these values are designed for a network, for a switch network with diameter of 7, means from the in the farthest farthest distance in the for example topology, we have 7 switch distance. For example, between the root bridge and the farthest switch, we have 7 hops, means 7 switch. But you know that here, for example, between the root bridge and the switch 4, we have only 2 switch. Because of that, actually the diameter of this network is 2. You can configure the diameter as is 2, and you will see that hello time, forward delay time, and max H timer, all of them are decreasing, and this means that we are experiencing lower convergence time, and this means that we are actually for example converting a network to a faster network. Okay, let me to show you these 2 features first: spanning tree VLAN, VLAN ID priority, spanning tree VLAN, VLAN ID root primary, root secondary, and also diameter option. After that, we can review the concept of spanning tree VLAN, VLAN ID cost, and spanning tree VLAN, VLAN ID port priority. Alright, this is our scenario. In this scenario, we have switch 1, switch 2, switch 3, switch 4, and switch 5. I want to configure the switch 1 as the root bridge and switch 2 as the, for example, root bridge secondary. And also switch 3, switch 4, and switch 5 should be configured with the lowest priority. Okay, let me to show you the default status. Here, the switch 1's MAC address is lower than the switch 2's MAC address and switch 3's MAC address, and also switch 4 and switch 5's MAC address, because the priority is default, and we can understand that the switch 1 now is the root bridge. Let me to show you here in this scenario, show a spanning tree. This is the switch 1. Here, as you can see, this bridge is the root bridge. This is the switch 1. Let me to change the host name. Host name is switch 1, and show a spanning tree. It can show us the priority of this switch is 32,768 plus 1. This is because PVSC, and means the priority is 32,768. After that, as you can see, that both gigabit 01 and gigabit 02 are designated ports. Here, the status of both ports are forward. The cost of both ports are 4 because you know that this is the gigabit interface. And after that, here you can see the priority number. You know that this is the port ID, and then type is P2P or point-to-point. It is so easy. All right, now let me to show you the configuration of switch 2, or the status of switch 2. Here we don't have any configuration. Actually, this is default status switch 2. Here, show a spanning tree. It can show us that the port gigabit 01 in the switch 2 is the root port. Okay, and also gigabit 02 and gigabit 03, both of them are designated port. It is, for example, obvious. And also in the switch 3, let me to show you the status. Show a spanning tree. This is the switch 3. Conf host name is switch 3. As you can see, the priority is 32,768, and after that, the port 1 is the root port. The port 2 is the block or alternate port. Okay, and as you can see, the port 3 is the designated port. It is so easy. Okay, after that, in the switch 4, this is the switch 4. Let me to show you the status. Enable conf host name switch 4. Show a spanning tree. It can show us that the port 1 is the root port, and port 2 and 3, both of them are designated ports. And finally, in the switch 5, This is the switch 5 enable conf-t. Host name is switch 5, and then show a spanning tree. Look at here. As you can see here, this switch has priority of 32,768. After that, as